All right, this is the second page of Notes 4.1 in Environmental Science, where we go over how the sun influences the climate. Okay, so what I've done here is I've ripped out this beautiful illustration from a German atlas about how the Earth revolves around the sun. Okay, so I looked through a bunch of different diagrams, and the best one by far that I could find was this one. So you'll notice that the first thing, the sun, zone, and the months are in the German spelling. So sorry, you can read it still. I'm sure it's fine. Some of it I translated, but yeah, this is everything revolves around zona dorm is another way that you can view this if you wanted to. All right. Anyway, so we're going to look here at what's called the equinox and the solstice. All right. And you've probably heard of these terms. Different holidays usually kind of center around them, or when you might hear people like, oh, we're just past the summer solstice, or it's the longest day of the year, or something like that. So we're going to talk about why equinoxes and solstices happen and what causes those. Okay. So let's just get oriented to this diagram. Okay, this shows the Earth at 12 locations. Each location is showing a specific month. So go ahead and just find where we are right now. All right, we're about right here. Okay, so this is the 20th of January, and the Earth is about here on January 20th. Okay, and what direction is the Earth revolving around the sun? You can see these arrows right here. And so the Earth is going around this way, okay? And you can also see the direction that the Earth is rotating. So right here, you'll see this little arrow, okay? So the Earth is spinning this way while revolving and orbiting the sun this way. And so we're getting a snapshot of each of the months that the globe is at. Okay, so let's pay attention to what hemisphere we're looking at. Can you tell from the map? Okay, here we've got Africa, the Horn of Africa. Here's Italy right here. Here's Spain. Okay, Iberian Peninsula is right here. Here's Greenland. Okay, so here's India right here, Saudi Arabia. So we are right now looking at the northern hemisphere. Okay. And we're looking at how the sun shines on it. Okay, now something you might know already, and if you don't, then here we go, is that the Earth is tilted on an axis. Okay, so we're going to look at this diagram to help us with that. And this diagram is the same exact thing, only we're looking at 4 stages, and it's just this tilted on its side. So if I were to take this and kind of tilt my diagram so that it looks like that, okay, that's the same thing as this. All right, it's just more of a 3D version. Okay, and you'll notice that the Earth is tilted on its axis right here. Okay, now the Earth never changes the direction that it's pointing. Okay, this is actually called the attitude. So I didn't include that because that's just another word that ends in "tude" to add, you know, the latitude, altitude, attitude of gratitude, all sorts of words that we're learning here. But anyway, the attitude of basically, it's always pointing a certain way, okay? The Earth always feels like it just needs to point that direction, okay? So as it revolves around the Earth, it's always going to be pointing in one direction with a 23.5 degree tilt of its axis, okay? So it's pointing one direction, and that actually changes how we experience the seasons here. So for instance, if we look here at January, you'll notice that the tilt of the axis, or the attitude of the Earth, is pointed that way, which means it's pointed away from the sun. Okay, so this little splotch, this black splotch that you see right here, okay, that's actually just 24/7 night that's occurring there. Okay, in the northern pole, in the North Pole, okay, in the winter time, they experience 24 hours of darkness, okay? And at that exact pole, okay, for 6 months, at the exact North Pole, you're going to have complete darkness for 6 months, okay? Because the axis is tilted away from the sun, okay? If I were to just show you here here's my globe, and let's say that here's the sun, okay? The sun is shining on the earth, but the northern hemisphere, the North Pole, is so far pointed the other direction that it actually doesn't even get any light, okay? So that means everyone right here is experiencing no light. All right, so that's kind of what's happening here with the earth, okay? So we see that on this little quadrant right here. And so what you can label this upper right quadrant is this is our northern winter. Okay, that's our northern winter. Now, at the same time, while this is a northern winter, and you can kind of see that right here, here's December, okay? What pole is pointed towards the sun? This one, okay? And because that pole is pointed towards the sun, it's actually going to be experiencing summer. And this is why your friends in Australia are having Christmas in summer, whereas you have Christmas in the winter, okay? So northern winter is at the same time that the southern summer is. Okay, southern summer and northern winter. So the southern summer happens, and you can actually see it on this line right here. These are the boundary lines of the northern winter. Okay, so when is the first day of winter? The first day of winter is the 21st of December. Okay, we often think of it, oh, like the winter started right after American or Canadian Thanksgiving, and so like we start listening to Christmas music in November, but November is actually not the winter. It's still the autumn, okay? Winter doesn't start till December, and it doesn't end until the 21st of March, okay? Now, the 21st of March, that is when you kind of have this medium, okay? It's quite even between the day and the night. So this is actually, I don't know if you can see this very well, but this half of the earth is experiencing night because it's pointed away from the sun on the other side, and this part is experiencing day. So as we rotate, we're kind of rotating into the light, and that's how the day happens, okay? So right here, as we move from March to June, you'll notice that the northern hemisphere is starting to point towards the sun. As we get on this side of the solar system, okay, we're pointing more towards the sun. Okay, so from here, we're coming out of the winter and moving towards the sun more, and that is when we experience spring. So that is the northern spring. Okay, and what's the opposite of spring? Well, autumn. And so that's what the southern hemisphere is going to be experiencing. The southern hemisphere is going to be experiencing autumn. All right. Now, so that's when we get to June, the axis of the earth is pointed towards the sun. So the northern hemispheres really starts experiencing summer, okay? It's starting to get really hot. We've been pointed towards the sun for a long time. And you'll notice the North Pole is actually, even as the earth rotates, it never actually gets out of the light, okay? Kind of like, if I were to show you this here again, the North Pole, now that it's on the other side of the solar system, the North Pole is constantly in the light. Okay, so the North Pole is actually experiencing 6 months of day at this point. Okay, now the further you get towards the equator, like here in Germany, we still have night, day, but you spend more time in the day. Okay, so yeah, at this point on this little quadrant here in our map of the orbit, okay, this is going to be the northern summer. And that's the same thing as the southern winter, because the southern hemisphere is pointed away from the sun. Okay, so that's kind of this quadrant right here. All right. And then we move here from September to December. Okay, you know that in the northern hemisphere, we're experiencing autumn or fall. Okay, so our fall semester is during that point, and the days are starting to get shorter as we move there. And that's because our hemisphere is kind of being pointed away from the light. Okay, so that's the southern hemisphere is starting to point towards the sun, so they are experiencing lengthening days. So that would be the southern spring, okay, season. All right, so you'll notice some lines here, okay? First off, here's my dotted line, and this is kind of representing the distance from Earth, okay? So here's when we're closest to the sun, and here's when we're farther away from the sun. You'll notice that this line is a little bit farther than this one, okay? And so this is called the aphelion, and it's when the Earth is 152 million kilometers from the sun, okay? And we're 147 million kilometers, which is closer on the 3rd of January, okay? Which I had mentioned in the previous video. So people who say that the summer is when we're closer to the sun doesn't make sense for two reasons. Number one, the northern hemisphere is experiencing summer while the southern hemisphere is experiencing winter. And so you can't just say the Earth's summer. Earth doesn't have a summer all at one time. Half of it has a summer while the other half has a winter. The second reason is, look how far away we are, okay? We're really far away from the sun when it's the summer. So it can't be the distance, okay? You'll notice this time, the December is a function, the winter is a function of, the summer is a function of how much time we're spending in the sun, okay? All right, so there's kind of your orientation to this diagram here. There's two other lines that we need to go over, and that's the solstice line and the equinox line, okay? You notice right here, this is the equinox line, and this is the solstice line. Let's go ahead and define what those terms mean, okay? The solstice just means sun still, okay? Sol means sun, and stis means staying still, okay? So the sun stops still at this tropic latitude, at a tropic latitude, and moves back towards the equator. Okay, I'll show you a video later just to show you exactly what all this means. But basically, on the December solstice, okay, December 21st, the sun shines directly above the Tropic of Capricorn, and we have the shortest day in the northern hemisphere. Okay, so let's go back to this map. Remember, this is the same thing as this map. It's just kind of like that, all right? So let's go back to this map here. And we can actually see the equinox line and the solstice line. So right here is my 21st of December solstice line. And notice how here's a sunbeam going perpendicular from the sun straight to Earth. And notice how it hits this nice little dashed line right here. Well, that nice little dashed line is what we call the Tropic of Capricorn. And it's basically where the sun is shining directly over right here for this solstice. So it's not even in the northern hemisphere, it's in the southern hemisphere during December. So there's more light on this part of the Earth, okay? So that's the December solstice. And that's for us when winter really begins. It's gonna be the shortest day of the year. Winter begins, and things are just gonna be really cold from then on out because we've just been so long in the northern hemisphere for so long in such little light, okay? Here you can see the line showing here's nighttime. Okay, and there's more night happening up here in the northern hemisphere and less light happening, okay? So that's the December solstice, okay? Now the opposite of the December solstice is the June solstice, okay? Okay, and it's when the sun shines directly above the Tropic of Cancer, and we have the longest day in the northern hemisphere. Okay, so let's go back up here. So as we move throughout the Earth, the sun kind of stands still over here, and then it starts shining directly above the equator, and then when we get over here, it shines directly above the Tropic of Cancer. So the Tropic of Cancer is just an imaginary line that we've drawn around the Earth to kind of represent where the sun is shining directly over on this particular day. Because what happens is the sun likes to shine directly up here in June, okay, here in spring and autumn, and then here in winter, okay? So the sun's kind of moving back and forth as the Earth revolves around it. All right, so June solstice, the sun shines directly above the Tropic of Cancer, and we have the longest day. So that's what a solstice is, and we call it the solstice because that's the farthest the sun can reach. And so when it reaches that point, it stands still and then starts going back. All right, now the equinox is basically, you can see the word equal in there for equa, and then nox is just another word for night. So equal nights. So on this day, the day and the night are equal. So you may have noticed in the winter, you have a really long night and a really short day, but by the time we get around to Easter, the day and the night are about the same amount of hours, okay? So during the March equinox, okay, March 21st, and when's the other equinox, okay? We can see that here's the March, so February, March, April, May, June, that's the solstice, July, August, September, okay? So here's the equinox line, and it goes to September. So the September is the other equinox, okay? The northern and the southern hemispheres receive equal light on this day, okay? And day and night are relatively equal length. Let's go up to this diagram here, and you can see why. So here's the sun, and at this point in the Earth's revolution in orbit around the sun, that Earth is rotating, and you have just an equal amount of night and equal amount of day. Okay, here you have like more night at the top and less day, but like over here, it's just perfectly equal. So no matter where you are in the world, whether you're in Copenhagen or Cameroon or South Africa, you're gonna have the day and the night are at exactly equal length. And that's why we call it an equinox. So if you hear people talking about the equinox, you can expect, all right, you know, the day and the night is gonna be of equal hours here. Okay, now some of that might be a little bit confusing. Hopefully the homework and another video that you'll watch for the homework will explain just how all of those things kind of fit together. But just keep in mind, it's the tilt of the axis and the direction it's pointed as the sun revolves around the Earth that determines why we have seasons, okay? And why it is that we have equinoxes and solstices. Okay, an equinox and a solstice are just the boundary lines between the seasons, and they're just defined by the amount of daylight relative to the amount of night. Okay, whether they're equal or whether they're, it's like the most night that you would have or the most day that you would have. All right, so let's go to the last page here. And we're gonna kind of look at different zones of the Earth, all right, and look at some different latitudes and lines, okay? So here's a diagram of the Earth, and at this point in its orbit around the sun, okay, the axis is pointed away from the sun, okay? So let's just answer these questions here. What event is the diagram undergoing in this diagram? Well, the Earth is the northern hemisphere is the farthest it can get away from the sun, and the southern hemisphere is the closest it can get. So what season are they experiencing up here? Oh, this would be winter. It's really cold. Okay, in fact, right here, it's pure night, all right? Down here, it's pure day, so it's summer down here. Okay, it's pointed towards the sun. It's gonna be receiving more direct light. In fact, if I were to use a laser to kind of represent that light, okay, that light is shining directly overhead right here and causing summer. Whereas here, it's just glancing up here okay, because it's shining away. And so all that light is being spread out and is really faded, okay, and less direct. Whereas down here, it's really, everywhere is really direct and really hot, okay? So this would actually be December. And is that going to be a solstice or an equinox? Well, if it were an equinox, the day and the night would be equal. But clearly, that's not really going to be the case here. In fact, if I wanted to draw what the day and the night looked like in this diagram, what I would do is I would draw a line, okay, straight through the earth like this, okay? And everything on this side that's facing away is night. Okay, don't shade this in too dark on your paper because we're going to shade in some colors here. But this on this side is night and this time is day, and so the Earth is going to be rotating like that. And you up here you see, if you just look at the northern hemisphere right here, how much of that is experiencing night? A lot, okay? There's going to be, the Earth spends very little time in the daylight up here. So the night and the day are not equal at this point. So it can't be an equinox. It's got to be a solstice. And that's, you got to just remember that solstices happen in the summer and the winter, but equinoxes happen in the spring and the autumn when everything's kind of medium and even, okay? So what season is it in Germany here? Okay, the season is going to be winter. All right, so I'm just going to kind of erase that there. So that just kind of shows you the night and the day there. All right, so let's look at the zones of the Earth, okay? So the first zone that we're going to look at is called the polar zone. And you're going to see a lot of cold biomes in this area. Okay, the polar zone is all latitudes where the sun does not set for at least one 24-hour period. Okay, so what that means is throughout the course of the year, you're going to have at least one day where the sun is always up for 24 hours. It never sets. You never have a sunset. And that's because whichever axis you're in, it's going to be pointed towards the sun so much that the sun is never going to actually disappear from view. Okay? So at the poles, at the exact poles right here, the exact poles, the sun is actually not going to set for 6 months. Okay? So for 6 months of the year, the sun is up, and for 6 months of the year, the sun is gone, whether or not it's pointed towards or away. All right? And because it spends 6 months of the year outside of the sun and it's so indirect, it actually ends up being the coldest place on Earth. All right? Even though the southern hemisphere right here, it's pointed towards the sun, and it's going to be experiencing, a 6-month day, because that light is going to be kind of indirect along the sphere. It's still going to be pretty cold. All right, let's just label the polar zones here. Okay, so this is the polar zone right above this line. Okay. And here's my North Pole. And at my North Pole, at this moment in time, am I experiencing a 6-month day or a 6-month night? A 6-month night. Because in this diagram, it's December. Now, for your homework or for a quiz or something, I might give you the Earth during like the summer or during the winter, or I might change it up, All right, so let's color code this here. I'm going to color code the polar zone blue. And go ahead and you can pause the video and grab coloring pencils. You are going to need 4 coloring pencils or highlighters or pens or something. 4 colors. I'm going to use these 4 colors: red, yellow, orange, and blue. You can use whatever colors you want to use. Okay. So I'm going to highlight the polar zone blue. And do I have just 1 or 2 polar zones? I have 2. Okay, the other one is down here where Antarctica is. Okay, it's just that thin little line. That's my polar zone. Okay, and at the South Pole, at this moment in time in December, I'm going to be experiencing a 6-month day. Sorry, I kind of spelled day weird there. 6-month day. All right, because it's just bathing in the sun right there. Okay, so those are my polar zones. Now you'll notice, you're probably wondering, what is this line? And these lines, this is a 2D image, so you're just gonna have to imagine that it's a 3D globe and that these are circles wrapping around, okay? But this line we call a particular circle, okay? And that is the Arctic or the Antarctic circle. The Arctic and the Antarctic circle. Sorry. Now, how do we define what those circles are? Well, basically, it's the latitude where the sun does not set on the summer solstice day, okay? And what that means is, for instance, right in here is the summer solstice day. And so right at this exact line, that's the only day of the year that the sun is always going to be in view for 24 hours. So the sun never sets. Now here below, like they're experiencing it for a lot more, but right at the edge of that, of the Antarctic circle right here, they're experiencing a 24-hour day. Okay, when it happens in the summer for the north, when the earth goes to the other side of the sun, okay, people call that the midnight sun. And if you have lived in Russia or maybe somewhere like really north, you might hear it called like the white nights or the midnight sun. And I mean, really, you can look this up if you haven't experienced anything like this, but you experience a 24-hour day. The sun never sets, and it's you're right there on the edge of the part where the axis is pointing so directly to the sun that the sun's always in view. Okay, so that's called the midnight sun. And that's up here, this is the Arctic circle. So I'm actually going to label this here. So this is the Arctic circle. Go ahead and label that on your paper. There's the Arctic circle. And then if I go down here, right here, this is the Antarctic circle, or anti-Arctic. Okay, that's why it's called Antarctica. It's just the opposite of the Arctic, anti-Arctic. Okay, Antarctic circle. All right, so that's Antarctic circle, that's the Arctic circle, and just that's the circle where everything above is experiencing that weird stuff with daylight and nighttime, where the sun never sets sometimes. All right, so now let's go to the next zone here. The next zone is going to be called the Temperate Zones. The Temperate Zones. Okay, and these zones mostly experience the 4 seasons, which are determined by the tilt of the Earth and its position in the orbit. Okay, so remember, seasons are not caused. You don't have cold winters and hot summers because of the distance. It's because of the tilt of the Earth. And they aren't really in the circles, the Arctic or Antarctic circle, but they are closer to it than the equator. And so what they start experiencing is they do experience extreme shifts in temperatures just as the Earth kind of travels around the sun, they're experiencing extreme shifts in how they receive daylight, okay? Now, there's a subcategory of the temperate zones. I'll just draw an arrow down here because it's a subcategory, okay? And these are called the subtropics. So it's not part of the tropics, it's part of the temperate zone. Basically, it's the warmest part of the temperate zones, and it's usually where the deserts are, okay? And it doesn't actually have 4 seasons. They experience a specific season based off of how much rain they get. So you may have heard of it. A dry season and a wet season. Dry and a wet season. Okay. Let's go ahead and color these up here. Okay. So my temperate zone, well, you might remember that we are in the temperate zone. And so I'm going to label us right here. Here's temperate zone up here, temperate zone. And the subtropics is right below this dashed line, okay? So here's the subtropics. subtropics. And it's part of the temperate zone. That's why I made the line dashed. Okay, so I'm actually going to color subtropics a little bit different color than temperate zone just because they are kind of different categories. So I'm going to use yellow myself to color in this temperate zone. Okay, so I'll color above the dashed line, and these are all the areas on Earth that, because they experience those intense shifts in daylight throughout the year, they do experience different seasons, the 4 seasons. So cold winters, hot summers, that kind of thing. Okay, which makes sense. All these areas kind of experience that, right? And the north is not the only place that has a temperate zone. Okay, the south also has it. Okay, so some temperate areas would be southern Africa and southern South America. And I'll color this the same exact color. I'll color it yellow. My temperate zones will be yellow. All right, so there's my temperate zone. Now let's label the subtropics here. You have subtropics on both sides. Okay, so here I have subtropics too. And I also have, you know, deserty areas kind of in those particular areas. We'll talk a little bit about why that happens in just a moment here, but I'm going to color these orange myself, okay? So let's color the subtropics orange. Dry, warmer areas with a wet season and a dry season. Okay, you might experience monsoons. So I lived in the subtropics when I lived in Arizona. That was kind of along the edge of the subtropics in the temperate, but you know, it's a deserty area. You have a monsoon season where you have these massive, beautiful lightning and thunderstorms that come in and just rain everywhere. And then you have a season where it's really dry. Okay, so those are the subtropics. You see a lot of deserts in those areas. Not as extreme as the temperate, but still a little more extreme than the closer you get to the equator, okay? Now, let's go ahead and, let's label these lines right here. So this dashed line, let's go ahead and label that. That's just 35 degrees north, and that's just the latitude. So I'm 35 degrees from the equator at an angle. Remember, that's how we measure these, okay? And that means that down here, what is this? If that's 35 degrees north, how would I mark this latitude? Mark it 35 degrees south, okay? All right, and let's just write a little note here. Okay, the temperate zone has 4 seasons, whereas the wet and dry season are in the subtropics. Wet and dry seasons, okay? Wet and dry seasons, 4 seasons, 6-month thing, okay? So at this stage in the game, remember the season that it's in is winter, summer, okay? Now, we need to talk about these tropics again because we kind of went over it a little bit in the previous diagram, but the Tropic of Cancer is the northern latitude that the sun shines directly over on the June solstice. Right? Directly over on the June solstice. So right now, this is not June, this is representing December, but if my Earth were, let's say that the sun was over here, if the sun were over here, right here, then this would be the summer, okay? In which case, the sunlight would be shining directly over this line, okay? Which means that this line right here is the Tropic of Cancer. Now it's called Cancer because Cancer is a constellation, and that was basically the constellation that was behind the sun when they named the Tropic of Cancer and when the sun was shining directly over it. So it has to do with constellations, okay? Now here, we'll talk about this later, but yeah, the corresponding line of the Tropic of Cancer we'll talk a little bit later, okay? So underneath the Tropic of Cancer, you'll see the tropics is our other zone, okay? The tropics zone, okay? And it's basically all the latitudes, all the areas where the noon sun will pass directly overhead on at least 1 day per year. All right. So that's this remaining region right here. And let's go ahead and just label this. Here, we'll label this tropics. Tropics. This is all one region. And I'm going to use red to color this one in, because red makes me think intense heat and sun. All right. So here's the sun shining directly over this area. Okay. And what you'll notice here on December, if I wanted to draw a line perpendicular to the Earth from the sun, okay, shining directly onto the Earth, here's a line perfectly perpendicular. You notice that it actually comes into contact with this lower latitude, okay? And what happens is as the Earth rotates around the sun, okay, if I were to move the Earth around and then we would be on the other side of the solar system, and let's say the sun were over here, and so then it would be summer up here, then the sun would shine directly over this latitude right here, the Tropic of Cancer. Okay, so as I move throughout the year, the sun kind of shines directly overhead in between these two lines. Okay, whether it's shining right over here or right over here, this area just gets the most direct sunlight throughout the whole year. That's what you need to know. Now, on at least one of the days per year, okay, there's a phenomenon that's a really interesting thing, and it's called zero shadow day. And zero shadow day is when the sun is directly overhead of you, and at exactly noon, if you're standing in the right spot, the sun is perfectly overhead, okay, and it's going to be right over you, that you're not going to cast any shadow. The shadow is going to be right underneath you, and so it's called zero shadow day. What this looks like right here, okay, can you tell here, this is the December solstice, so this is December 21st in this diagram. Who is experiencing zero shadow day? Anyone on this line, okay? Remember, the Earth is rotating right here, so anyone on this line is going to be brought up to this little location. So at exactly noon, the sun is going to be shining right overhead, and that person's going to be experiencing zero shadow day. Now, when the Earth rotates, it kind of revolves around and goes around the sun. The sun is going to change where exactly it's shining directly overhead. So like the next day, a person right here would experience zero shadow day. The next day, a person right here, that kind of thing. All right. So on the equinox, anyone at the equator will be experiencing zero shadow day. Okay. Remember, our definition of the equinox is when the hemispheres receive equal light and the sun is shining directly over the equator. Okay. Well, this line right here is the equator. Let's go ahead and label that. Okay. And on the equinox, the sun is going to shine right over there. You can kind of think equinox, equator, and people there are going to be experiencing zero shadow day. So they actually have it twice a year because the sun will shine directly over it. If this is confusing to you, don't worry. It'll make more sense as you do your homework and watch some more videos that I made for you. All right, so there's that's what the zero shadow day is. Now, let's just talk for a moment, and this is an important thing, so really pay attention here, okay? We got to talk, why are there so many rainforests here? Okay, you'll notice Brazil's right here, so you got the Amazon rainforest right here. You've got Congo, you've got a lot of different forests that happens. The Sahara's right here in the subtropics, but right here you've got a lot of rainforests and jungles, okay? Even if you go over here, you get Indonesia and stuff, and Papua New Guinea. All right, so the reason why it includes many of the world's tropical rainforests is because the direct heat evaporates water, which will then condense and fall as rain. Okay, so what happens here is I have intense heat in this area. Okay, all that water is going to evaporate and form clouds. Okay, those clouds will then, as they get higher up into the atmosphere, it gets colder. Now, what happens to water when it gets cold? It condenses into like raindrops, right? It condenses into clouds and then falls as rain. So you get a rainforest because the water is so hot, it heats up, it evaporates, and then once it gets cold up into the air, it forms together, forms water droplets, and then comes down as rain. So you get a lot of rain in this area, and it's because of that heat. Okay? Now, here's the thing though. If all that air is up here, and that air is going to be floating around up here, and there's specific winds that take it to certain places because of the rotation of the Earth. If all that wind is up in, actually, let me just take this, put it down here, okay, to make it a little more 3D, okay. So here's the water evaporates, it comes up here, condenses, falls as rain. Then up here you have dry air, and that dry air is going to float either up north or down south and then descend. And when you have dry air descending and it's still hot near the surface, you get a desert. So you get this desert of dry air, dry land, no rain. And the reason why the Sahara has no rain is because all of the rain fell in the tropics before it ever got to it. So that's why we see deserts, and that's why you see this pattern around the world where if you just look at a map, you'll see it. Green forest, desert, and then green forest again. Okay? Green forest, desert, green forest again. And it's just because you lose so much moisture from the rainforest. It sucks the air dry, and that air then falls on the deserts. Okay. All right, so we've labeled the equator, the Tropic of Cancer, okay? And here at the equator, okay, you're going to have 12-hour daylight for the whole year. A year-long 12-hour daylight. Year-long 12-hour daylight. Okay, and there's just a lot of consistency here, okay? Up here, there's so much inconsistency. Down here, there's a lot of consistency, okay? Because it doesn't change that much over the year, okay? It's not pointed away or towards the Earth too extremely. It's just kind of in the middle. In the middle, it's not very extreme, okay? Ooh, all right, let's go down to this last blank, which is pretty important here. All right, this is the Tropic of Capricorn. Okay, it's the line of the Capricorn. It's just an imaginary line. Okay. Capricorn is in the south, and again, Capricorn is just it's a constellation. Okay, it's a southern latitude that the sun shines directly over on the which solstice does it shine directly over on? Well, the June solstice was the Tropic of Cancer, and so this is what it's shining directly on. It's December solstice. Southern latitude that the sun shines directly over on the December solstice. Okay, so again, remember this diagram here is of the December solstice. And so at this position in Earth, where the Earth is in the solar system, you're going to see that sun shining directly overhead. Okay, it's shining on that little area right there. And so this line is what we call the Tropic of Capricorn. Now, this is a little bit confusing. I used to always confuse these because I think corn kind of sounds like north, and so I kept thinking Capricorn was in the north. Just think it's the opposite of that, okay? So Capricorn sounds like north, and it's the opposite. So it's Capricorn is actually in the south, and Cancer is in the north. It's kind of hard to remember. Sorry. All right, so right here, at this exact little place right here, the December solstice is when the sun hits the Tropic of Capricorn. Okay, the sun hits the Tropic of Capricorn right here. Okay, and that's how we define what the Tropic of Capricorn is we define it by when the sun kind of rests right over it in December. And then as we go January, February, March, the sun kind of points up here. March, April, May, June, up here it points. July, August, September, September, October, November, December. Okay, so the sun, just as the earth is going around. Okay, let's go back to this diagram to show you. Here the sun shines directly over the Tropic of Capricorn in December. It's going to shine directly onto the equator on the equinox, and then it's going to shine over the Cancer tropic on June, and then the equator again, okay? So that's this diagram kind of shows you. I could show you any one of these diagrams, and you'd have to answer different questions on it, which you're going to do with your homework, okay? So at this point, when you're done with that, okay, your next lesson will be to start working on your homework, okay? So, yeah, on the homework, you'll answer some different questions on what you've learned here. Please be sure to watch the video that I've made where I go to the gym and I kind of show you with an actual globe how all this stuff works, because sometimes it's hard to visualize this on a 2D diagram. But when you see it in person, it helps you visualize it a little bit more, okay? So that is the end of Notes 4.1. We are now done with that.